So let's continue our tutorial, and during the second part of the geostatistical interpolation methods using geostatistical wizard, we will work with the another type of interpolation. It's called geostatistical methods, and the most advanced geostatistical interpolation method is Kriging or co-Kriging. So open the geostatistical wizard and click to Kriging, co-Kriging, and click and at first we should again set the dataset and the data field, and as a source dataset we don't have to specify this. So at first, just a short introduction to Kriging, co-Kriging. Kriging is an interpolator that can be exact or smoothed depending on the measurement error model. It is very flexible and allows you to investigate graphs of spatial auto and cross correlation. Kriging uses statistical models that allow a variety of output surfaces, including prediction, standard errors, probability, and quantile. The flexibility of Kriging can require a lot of decision making. Kriging assumes the data come from a stationary stochastic process, and some methods assume normally distributed data. So let's click next, and we will start with ordinary Kriging. You can choose here the transformation method, transformation type. Using transformations makes variances more constant throughout your study area and the data closer to being normally distributed. Order of strand removal. You may want to remove a surface strand from your data and use Kriging or co-Kriging on the detrended residual data. So output surface type, we will make prediction, and here is our semi-virogram map. So let's go to the ArcGIS help, and let's first make a differentiation between different types of Kriging models. Kriging methods depend on mathematical and statistical models. The addition of the statistical model that includes probability separates Kriging methods from the deterministic methods described in deterministic method for spatial interpolation. For Kriging, you associate some probability with your prediction. That is, the values are not perfectly predictable from a statistical model. Consider the example of a sample of measured nitrogen values in a field. Obviously, even with a large sample, you will not be able to predict the exact value of nitrogen at some unmeasured location. Therefore, you not only try to predict it, but you also assess the error of the prediction. Kriging methods rely on the notion of autocorrelation. Correlation is usually thought of as the tendency for two types of variables to be related. For example, the stock market tends to make positive changes with lower interest rates, so it's said that they are negatively correlated. However, the stock market is positively autocorrelated, which means it has correlation within itself. In the stock market, two values will tend to be more similar if they are only 1 day apart as opposed to being 1 year apart. This is related to a basic principle of geography. Things closer together tend to be more similar than those that are farther apart. The rate at which the correlation decays can be expressed as a function of distance. Autocorrelation is a function of distance. This is a defining feature of geostatistics. In classical statistics, observations are assumed independent, that is, there are no correlation between observations. In geostatistics, the information on spatial location allows you to compute the distance between observations and to model autocorrelation as a function of distance. So I will not waste your time within this video, but I urgently ask you to read this ArcGIS help. So can also change this to covariance. I prefer semi-variogram, and two sectors we will use, predicted value, weights also. Kriging method uses autocorrelation, which means correlation with itself. So here are our samples, right? Source ID included, measured. You can see the measured and predicted is the 100 points, right? And here you can see the differences between the measured and predicted according to the ordinary Kriging. The error in some places big and in some places are low. Standard error and standardized root mean square. So okay, let's click OK, and here is our prediction map. You can close this. So again, we should change the specify shape into region, right? Stand to the region. So here is our prediction. Kriging. We should also use other types of Krigings, right? Using height, simple Kriging, see it a little bit differs from the ordinary Kriging. Click next, and see also the prediction and measured. It's strange that it's changed. It doesn't change. So our simple Kriging also created, and let's start. Let's also try universal Kriging. I will not change the values. You can also choose here the kernel function, but I will leave it to 4 factors. I think it's prediction errors. Prediction Kriging differs from the I know it's universal Kriging. Let's try it. Should also know well the geostatistics. And not just geostatistics, you should use the statistics very well to understand all these geoprocessing concepts, because for me actually this is also hard to understand. So I know the work principle of the ArcMap, but not knowing just perfectly the statistics itself, it's hard to fully grasp the geostatistical analysis tool package. So I will skip probability because it's another type of Kriging, and let's click next. So this is disjunctive Kriging. Finish. Okay, and it's disjunctive Kriging. So I will merge them. I will group them into one group, ordinary. So no, I cannot group them because they are all not data sets, right? So I will export them in as raster datasets using this function, right? I will use this output cell size, which is automatically given. So I will pause the video here and please try to export all the of your Kriging layers into raster dataset. So I already finished my interpolation with Kriging. Actually, by the way, I forgot to here change in some cases object ID to height, so do not repeat my mistake. At first you should change the object ID to height and choose interpolation methods. You can work and just test several interpolation Kriging methods, but for filling the table we need only three: universal, ordinary, and disjunctive. So when we exported our layer as a raster, so here is our results, minimum, maximum. We should also check the root mean square and root mean square standardized. So minimum, maximum we can find also in the symbology, 431 and 1096, right? 1096. And root mean square we can find in the in our statistical layers, right? So so it's ordinary Kriging. We can find the root mean square and root mean square standardized. Here's our root mean square, 387, and standardized is here's root mean square standardized, it's 1 approximately. And the last one is disjunctive. I don't know why, but the results of my disjunctive Kriging gave only one this mean value. I think we should learn more about disjunctive Kriging method. Probably the methodology of disjunctive method differs. So the values of here during the statistics differ, but when I here see, oh, it has only mean. Probably the methodology differs, so minimum and maximum doesn't contain and root mean square error by the disjunctive method. Root mean square is 365, a bit smaller, and the standardized is 0.99, so even smaller. So we can see the major differences between these statistical methods of Kriging, right? Say it, Kriging. So why we can need a geostatistical analysis tool package? Because it contains much more options comparing to just Arc Toolbox during the interpolation method, but mostly this geostatistical analysis tool package used mostly during the professional work, where while we need more advanced computations, and we can while we need more input data and more precise analysis according to our work. So you can find more about the geostatistical analysis in ArcGIS help. Here can also works with this tutorial, and but just to let you know that just reading this information is not enough, because it also needs you also need basic knowledge, not just basic knowledge, but advanced knowledge of statistics. So by the way, you can also export you can make from this continuous map the discrete raster dataset using Gray classify tool, and calculate areas of each class. You can also change the number of classes right here, number of classes, etc. So now I pause the video and finish this geostatistical analysis and interpolation methods tutorial.